Okay, ladies and gentlemen, Cameron Say again, moving right along on Master the Mainframe 2017. We're now on Challenge 4, Part 2. And I'm a little embarrassed to say that this challenge took me much longer than it should have, but I think in the course of my finding out, and it really is pretty simple, but I was thinking too hard, and I was looking for a much more complicated solution than there was, which is easy to do. Um, and so I think that my struggles with this particular challenge may help me to kind of explain some of this to you. So I have my um, uh, let's bring up the Master Mainframe website. Yeah, I'm using the website instead of the PDF now because it gives me it's smaller and it gives me more on the screen. So there's a lot of background here about JCL, and JCL is the abbreviation for Job Control Language, which is the way that the system manages the work that it has to do. As we said earlier, there's a lot of complexity to what a mainframe does. Complexity in terms of the number of jobs that it is intended to support at any given time, and what those jobs have to do. And we're talking about tens of thousands of jobs. Um, an unimaginable amount of work. And so the system has to have some way to keep up with all of this. You got to understand that this technology really does what no other technology does. Even supercomputers. I mean, supercomputers certainly can handle multiple tasks simultaneously. And just for you novices, I don't need to explain this to the veterans, but a digital computer really never does anything um, more than one thing at a time. It really never does anything concurrently, but it just switches between tasks so rapidly that it appears to be doing things simultaneously. But it does it processes one instruction at a time. It does it very very fast. So JCL is what helps the mainframe do that. So there's a lot of good background here, and we're going to play around with a little COBOL. Now, we're not going to do a deep dive into COBOL. COBOL is not a complicated language. It's probably one of the easier of the higher level languages. Um, it's not as easy as something like PHP or Rex, but certainly is easier than something like Java, a language like Java. It's not object-oriented, although there is an object-oriented COBOL model that exists. But yeah, COBOL, there's a rich history of COBOL that we won't go into now. But anyway, this is giving you some understanding of JCL. So, and we will cover JCL thoroughly as your training progresses. Master the Mainframe is just to give you an introduction to kind of a high level of mainframe functioning with a lot of hands-on. But we will give you structured and detailed training in things like JCL and COBOL, things like that, in preparation for your mainframe apprenticeships. And in that course, you certainly will be qualified for a non-mainframe apprenticeship. So if you can have a mainframe, certainly do other stuff. The three main types of statements in JCL are the exec, the DD, and the job statement. So the background gives you a little information about those, and we will discuss all those later. So yeah, read all this stuff. You can read that yourself. I don't have to read it for you. And I'll do Q&A for any questions that you have for this. But we're going to get to the meat of the challenge. I think a lot of this I can explain to you. So we're going to go into, go back to our system. I've logged on, and let me start from the primary menu. So you can stay up with me. I think hopefully you can get to the primary option menu by now. If not, go back to earlier videos. It shows you how to do it. So this is the primary option menu. And so here we're going to do a 3.4 to go to our data sets. And you see there, these are my data sets. That's my ID there, Z00745. What do we need to do? So we need to go into a data set called source, where we have source code. And we're going to put E there. Go back to the instructions. And so now we're going to select the member, CBL RDWR, and I'm just going to call that our program, because it's a hard acronym that, those are too many letters to say over and over again, so I'm just going to call it the program. But when I say program, I mean the program CBL RDWR. And so we're going to select that. Now it says selected because we're really not going to make any changes in the COBOL. But here I can point out to you that, and as your training progresses, you will see that there are a couple of ways that you can compile a program. One of them is to have source code, and source code is the code that you write, right? You write it in syntax that you're familiar with. So you write that source code, usually a text file, an ASCII text file. Well, you don't know, well, I think we covered what ASCII was in an earlier challenge. So you just run the COBOL through JCL. You combine JCL with the COBOL, and you do it one step, as opposed to having a COBOL, having a job. And this challenge really shows you both ways. So it really is good. So here we have some source code, and as I said, we're not going to get into a lot of COBOL, but COBOL has division. So it's identification division, environment division, environment division, data division, and procedure division. Okay. And here I don't think we have a data division. Yeah, we do have data division. Sorry, I have a data division here, and then procedure division. Now the procedure division, the identification division, of course, identifies the program, and it has at minimum the program name, but you can have a lot of other information in the identification division. The environment division outlines what your working environment is. The data division has your data, it defines your data, and the procedure division is where the logic of your program exists. So this is a very simple program. All it's doing is writing one line, outputting one line. So if this is mysterious to you, don't try to absorb. The point of this challenge is not to make you proficient in COBOL. It's just to show you the relationship between COBOL and JCL. That's the point of this exercise. COBOL and any other language in JCL. So we have some COBOL syntax up here, and we have a job statement, and it's called job 1. The name of the job is same as the program. Sorry, that's the name of the job is CBL RDWR, or our program. That's the name of the job. The exec statement tells us that we have to execute a program. So here we're going to have a couple of things. So this ITYW is what's called a proc, or a stored procedure. That is just code that has been written. and you call on to perform certain tasks. In this case, we're going to compile a COBOL program and we're going to link it. The C means compile, the L means link it. And I might as well tell you now, there's going to be a lot of information in what I'm going to say in this challenge, but I don't need you to absorb it all. We're just going to discuss this at a high level. So the process of compiling, now this is not just about COBOL, this is about COBOL and any other language that needs to be compiled. You have to convert it, or I guess the proper term is translate it from source code to machine code, right? We've discussed that computer processors only speak one language. That's binary or machine language. They're synonymous. Binary and machine are synonymous. Ones and zeros. So there's got to be some way that we get this text that you see here before you. It has to be converted into something that the processor can perform upon. And that process is called compiling. Now, there's another step that is not discussed a lot, but I certainly talk about it in my classes, and you need to understand what's going on here. That L stands for link. So once I've compiled the program, it's not ready to execute yet. It needs to be further modified to enable it to be to execute. So once you compile it, it's in binary form, and then when you link it, you have to provide other systems resources. There are things called address resolution, things like that occur during the linking process. So it's another step that makes the program executable. Once it's linked, then you can execute the program. You've got a what's called a load module or an executable module, and sitting on your machine somewhere. And we'll talk about real storage and auxiliary storage down the road. But once you link it, then it can be executed. So that's what this step right here does. IGYW is the compile prompt, and we tell it to compile and link, right? And then we want to compile, we want to run the program, CBL, RDWR, or our program. And then what follows here is the actual program itself. So this DD star means I'm going to read from line 100 all the way down to line 2860. Okay, and I'm going to read that, and that's going to be the input for this statement here. That's the program. Okay, so let's look and see what the program does. Well, one of the things that are important in this exercise, I want you to pay careful attention to line 700 through line 900. So that's file control. I've got to link external sources and give them some type of a reference internally to this program. So I'm going to use something, I'm going to select something called rec-n, but I'm going to assign it to an internal name, rec-n. I'm going to select something called print-out, and I'm going to assign it internally to something called print. Okay, so that's going to factor in to the exercise considerably. Now, the file section, line 1400 and 1500, just define storage area, as does line 1970 and line 1980. They just define a storage area, and I'm going to call those storage areas rec-storage and print-storage. Okay. And again, I want to caution everyone: if this is just a big cloud to you or a big fog to you, don't worry. Okay, don't worry, because for some of you, this is the first time you're looking at any of this stuff. It takes time for it to sink in, but it doesn't take forever. And hopefully, if you stare at this as long as I've been staring at it the last couple of days, I'm embarrassed to say, the fog will begin to lift. And this stuff is not as mysterious as it seems at first blush. Yeah, it is sophisticated, but you can manage it. Okay. And it's just about familiarity and having someone explain things to you, what stuff means. And I don't claim to be an expert in anything but just teaching this stuff. I'm an expert in that, and I'm an expert at just teaching an introductory level of it. But a lot of it is still mysterious to me. So I'm only a little bit ahead of y'all. But we've put a lot of students into careers in this, and so apparently, we've been doing the right thing. And I hope you will trust me that this stuff is very manageable with time. But it is going to take some persistence. So we define rec storage and print storage. Moving down to section 2010, more storage areas. So that's all you have to know. Now, those are just places that we're going to store things. Don't worry about the 0, 1, 0, 5. Those are levels. We can talk about that when we talk about COBOL more in depth. And we're going to have assigned values to them, N and Y. Okay, that's what's happening there. Pick is a picture clause, and we don't need to worry about a picture clause right now. Again, I'm going to try to keep the COBOL syntax discussion to a minimum because I don't want to confuse you. You really don't need it to complete this challenge. So the procedure division is where our logic begins. So I'm opening an area called recin file, and I'm opening a file called printout. So those files are open for business. I can read from them and I can write to them. And then now this is a loop, and for you folks that have some familiarity with programming, you'll know what a loop is. But if not, I refer you to the W3 Schools site. It can give you some information on looping, and we will talk. Now I've also put up, I think, some zip files for C programming. I put that on the bulletin board. So that discusses loops. But we're going to loop something. We're going to perform until last rec, and then we have this stuff that we're going to do. So when last rec is true, right? That's what it means. Perform until last rec is true. Read a line from rec in, and read until last rec is set to true. Okay, last rec is set to true, and program knows when it comes. There's a marker in the data that says I'm the last record, so it knows when it's come to the end of the list of data, and it'll set last rec to true, and that will essentially end this perform until loop. And then when you're out of the loop, if last rec, well, you're still in the loop now. I'm sorry. If last rec equals no, then so it's continuing on. So as long as last rec is in, it writes something from print storage, writes something to print storage from a storage location, rec storage. And then it ends the if statement, and then it ends that perform, right? So the loop is done. And then what you're going to do here is you're going to take the string COBOL is easy and write it to the location rec storage. Then you're going to print that to a location called print storage. Then you're going to close rec in, close print out, and then stop when ends the program. All right. So that was kind of a quick discussion of what this program does. And again, if it doesn't all stick, don't worry about it. That's fine. So that's what this program does. Now it says we're going to submit this job. Remember, this is a job. It's got at the top of it, it's got COBOL syntax, right? I mean, it's got JCL syntax. So we can submit this job, and it tells us to chain a couple of commands together. So what I'm going to do is put a semicolon to chain the command. I'm going to say SD, which starts our SDSF, and then I'm going to say ST, which gives us the status of my jobs. Okay, so this should run with no errors. So this syntax is, again, this is submit this job, go to this SDSF, the output location, and then do status. is separated by semicolons. So that's how you pipe the jobs together. And I've submitted a job 9548. So let's see if it runs together. Now, yeah, so I didn't have any errors. And so I told you I was going to show you a trick. You can either hit F2 or F1. I mean F2 once or twice, depending on your computer. On mine, I hit it once. That allows me to toggle screens. So once I've done that, then I can toggle from one screen to another with the F9 key. Okay, so I'm toggling back and forth. So now I want to do a status of my, oh, I don't need to do a status of my job. It already has a status there. And gotta do ST again. 9548, yeah, 9548. That's the job there. And I'm just going to look at it and see if the return code or RC equals 0, which it should. Right, so the return code is here. That means that job ran correctly. This LKED right here means that it was linked. It was compiled and linked. So now it's ready to be run. Now it's ready to be run. It's sitting somewhere. I've got an executable file. It's sitting somewhere, and it's ready to be run. Okay. So that worked. Now I'm going to toggle back. Oh. And okay, so I'm going to now, let's say do that. We did that. We used an S to verify that that job ran correctly. Return code was equal to 0. Right, so it says that to compile the COBOL source code. Now, what we're going to do is, I'm going to do my little copy trick here. Oh, I keep hitting bad keys, y'all. I'm on a laptop that has my, I have to hit the function key before I hit the F keys, and it's kind of messing me up. Let me just back out of this. I can't toggle very easily here, so let me just get out of all of this. Okay, now, okay, so I'm going to TSO submit JCL job for it. Again, the TSO, so it's after 1 o'clock, y'all, I'm sorry. TSO, I'm submitting a job, JCL, job 04. So I do that. Now, I'm gonna go back to SD. That job was submitted. I have an error, right? I have an error. So let's see what's wrong. So it's this job here, and I put a question mark because I want to see kind of what's going on, why my job didn't run. And the instructions say look at the sysout location, sysout DD name. Right, that's an output location. So I'm gonna put an S here, and it says I had an unsuccessful open or close of file print in our program. So that is my error, and the fix is really simple. I'm not going to tell you what it is, but I'll help you. I'll help you along with it. Show you what you need to do. So read the directions carefully. And let's look at that job. Look at that job. Equal signs, we got 4. And let's look at, let me clear this off so you don't get confused about what you're seeing on your screen. This way, okay? I'm just going to use one screen at a time. Let's look at in JCL here. Let's look at job 4. Okay, so there is something wrong here, okay? And remember what it said. There's something wrong here. Remember what it said. Let's read the comments here. The assigned to value must match the JCL DD name. So that's something I want you to focus on. The assigned to value must match the JCL DD name. These are JCL DD names here. These are DD names. And I took way longer to do this. You see here, this is rec in and this says rec out. So and let's go back to our problem statement. So keep this in mind. Rec in, rec out, okay. And let's go back to our jobs and let's go back and see what the problem was. As it said, look at the, and I did that by, let me back up so you can see what I did. I took the job that I ran, and you can purge your jobs. So I don't know if it shows you this in the book, in the directions it may, but you can just put P by every job that you want to get rid of. And then you hit enter and it'll just take them out one by one. And then when you do another ST, you'll only have the jobs that you take this one out. Okay, so yeah, now put a question mark here, a job 4. That'll bring up this as per the instructions. You put an S over by sysout location and say there was an unsuccessful open or close of file print. And you can use F11 to go right or left if you have more text, but you don't need any more text. I mean, what you need to look at is there was an unsuccessful open or close of file print in our program. There was an unsuccessful open or close in file print. And now I want you to look at the job we ran. Look at this real hard. There's something here that needs to be changed. There's only one value on the screen that needs to be changed. I'm not going to tell you what it is. But, if you understand what that value is, then you kind of understand what the exercise is trying to tell you. I'm going to pause this. So I started mine from the beginning. I'm going to pause it, the recording. I'm going to do the fix and I'm going to run it and I'm going to show you what the result's supposed to be. Okay, I've made the change and I'm going to show you the result of that change. I'm going to go into SD. I ran the job again. And so this is the job that I just ran. Let's look at the one previous, right? That's the one I ran before. And it didn't run, right? It says right here, didn't run. Okay. Now This is the one I ran after I made the correction. It was a very simple correction. And they told me this. It took me 2 days to stand this thing. I'm so embarrassed, but that's okay. That's IT. You know, that's IT. Here we have return code 00. Now we can see, I'll show you how you can tell if you did it correctly. I'm gonna put an equal 3.4 here, and I'm gonna go look at where it says the output is supposed to be. P2 output data. I'm gonna look for what? It's a very finicky beast. And I'm going to look in 4. I'm just going to view it. I don't want to mess it up. And it says sequential input record COBOL is easy. That's it. You're done. That's challenge 4, part 2.